Welcome to the project demonstration of speed synchronization of AC motors by using Zigbee technology. So here we are going to control the speed for these two AC induction motors in 10 speed levels. So we are using the AC motor which ratings of 1400 RPM maximum and is 1.7 ampere ratings for the each motor here we are using, and the speed of these motors controlled through the triacs, the BT136 triac we are using to control the speed of this one, and based on the input trigger pulse from the PIC microcontroller here. Here coming to the ratings, as we discussed, is 230 volts, 1.7 amps, nothing but around 400 watts. It's above of HP motor we are using to control these speeds here. So we are providing the 230 volts power supply for the motor through the triac board, and 5 volts from this adapter to the microcontroller. Same here also, 5 volts for the motherboard and 230 volts to the motor. So we are using the transformer to get the zero crossing point with help of this zero crossing detector. So coming to the main components at the master motor. So here we are using two motors, a master motor and a slave motor. The communication between these two is through the Zigbee module. So the master transmitter, slave receiver. So the Zigbee module which will act as a transmitter, and these are the 10 push buttons to provide the input to the microcontroller to set the speed levels, the 1 to 10. And this one is a triac board, so BT136 triac board, and this one is a step down transformer which will take 230 volts AC to 12 volts of AC, and the output of this transformer is input to this zero crossing detector in order to inform to the microcontroller when the positive waveform starts. Then only it will control the timing. There's a firing angle to set the speed of this AC induction motor. So the main components on this one, zero crossing detector is rectifier to convert the AC to pulsating DC, potential divider circuit to make that 12 volts pulsating DC to 5 volts pulsating DC. Why? Because controller can measure up to 5 volts maximum. So that 5 volts trigger pulse input to the base of this transistor. So here this pulsating signal of sine signal will be converted into square signal with help of this transistor, and output of the transistor is input to the B0 pin of our PIC 16F877A microcontroller. So initially the system will wait for the input from this keypad. There's a 1 to 10. After selection, that based on the input signal from that one, it will read the firing angle, and then it will set the firing angle to the motor to control the speed through this triac board. Coming to the interfacing connections, Zigbee interface at the pin number B1, and these 10 push buttons interface to C0 to C7 and D0, D1, and A and E port interface to this LCD. And mainly to measure the speed of this motor, we are using IR sensor here, which was connected to the A4 pin of our microcontroller. Zero crossing is connected to the B0. So these are the main input and output connections at this master motor. Coming to the slave motor, same like 230 volts AC input is connected to the motor through this triac, and parallelly to this transformer, step down transformer, same that 12 volts AC is input to the zero crossing detector. Same components here, and output of this one is input to the B0 pin of 16F73 microcontroller, and here B2 to B7 is connected to the 16:2 LCD screen. Same A4 is connected to the IR sensor, and Zigbee interface at the C6 C7 of our system. So when we set this one, then the system will inform to the slave motor to the Zigbee the motor level speed. Then it will set the speed of this motor to the same master motor. So if you want to change the master motor speed, just reset this motherboard. So here we are using the restart switch. So you can see this is a restart switch, press and release restart switch, so that we can set the speed again. But coming to the slave, no need to reset this slave motor. Automatically when the master motor changes the speed, it will match to the master motor speed of the slave motor. So let us see demonstration on the power supply. First of all, adapter, then we can see the welcome message and motor. When we on the power supply to the motor, we can see some jerk. The same for the slave motor, power supply, and on the power supply to the motherboard. Right. So this should be displayed. See speed 0 RPM. So if it is not displaying the speed 0 RPM, that is a problem of this particular cable is not getting the 230 volts. Why? Because it should get the pulse signal from the zero crossing detector. Here enter speed limit. So let us see the speed limit for 1. So after we select the 1, press and hold. So level 1 displayed. So then we can see the slave motor is tuned to the master motor speed. We are using the 140 rpm. So as we have divided the 1400 rpm of this master motor to 10 levels, so 140 and 280, so like that the speed was set. So if you want to change the master motor, then we need to reset that. When you reset this one, only the master motor will get switched off, but the slave motor keep on rotating with the master motor speed. So now I'm changing to some around 7th level. So level 7, right, we can see that automatically the speed got changed. Again we can reduce that, reset that. Two. So you can see that again. So while demonstration, we are not supposed to touch on this triac board as it totally passes with 230 volts here. Same on this triac board also. Now let us go with the high speed level 10. Right. So in this manner, we are going to synchronizing the speed of two AC induction motors with help of Zigbee technology.